question of whether the National Electrical Code (NEC) is involved in electrical repairs, especially in older homes not up to today's adopted NEC, is a common one. Generally, the NEC is not retroactive. This means existing electrical installations don't automatically need to be upgraded to the latest code version unless specific conditions are met. These conditions primarily involve major renovations or alterations impacting the electrical system, situations creating a hazardous condition, or work specifically mandated by the NEC or other applicable codes. Let's consider a residential property first. If an electrical problem is limited to a few outlets and lighting fixtures, an electrician might be able to address the immediate issue without necessarily bringing the entire electrical system up to the current code. However, it's highly recommended to have the electrician conduct a thorough inspection of the entire electrical system to identify any other potential hazards or code violations. If such violations are found, the electrician should recommend the necessary repairs to achieve code compliance. It's possible that an electrician might decline to work on a property due to potential liability concerns. In such cases, it may be necessary to engage a licensed electrical contractor specializing in older homes and their unique challenges. Now let's shift our focus to commercial properties. The rules governing electrical work in commercial buildings are generally more stringent. When renovating or altering a commercial building, the work typically must comply with the current code, even if the work doesn't directly affect the electrical system. This stricter approach stems from the fact that commercial buildings are often considered places of public assembly, necessitating high safety standards to protect occupants. Liability is a crucial consideration for electricians. They can be held liable for injuries or damages resulting from their work, irrespective of whether the work adhered to the NEC. However, by meticulously following the code and adhering to industry best practices, electricians can significantly minimize their liability risk. Here are some additional points to keep in mind. Firstly, even if the NEC doesn't mandate bringing existing electrical installations up to code, it's generally considered a prudent practice to do so during any major renovation or alteration. Secondly, homeowners bear the responsibility for maintaining their electrical systems in a safe and code-compliant condition. Thirdly, it's paramount to engage licensed and experienced electricians for any electrical work, ensuring the work is performed safely and in accordance with applicable codes. To delve deeper into the specifics of NEC compliance, let's explore some key areas. Firstly, understanding the scope of work is essential. Is it a minor repair, a major renovation, or a complete overhaul? The extent of the project will significantly influence the applicability of the current NEC. Secondly, identifying any hazardous conditions is critical. This might involve exposed wiring, overloaded circuits, or outdated equipment. Addressing these hazards is often a priority, regardless of the age of the installation. Thirdly, determining the local jurisdiction's requirements is vital. Local codes may have amendments or additions to the NEC, so it's crucial to be aware of these specific requirements. When assessing an older electrical system, several common issues often arise. One common issue is knob and tube wiring. This outdated wiring method lacks a grounding conductor and is more susceptible to damage and deterioration. Another issue is insufficient ampacity. Older wiring may not be adequately sized to handle the increased electrical loads of modern appliances and electronics. A third issue is outdated electrical panels. Older panels may lack sufficient circuit breakers or safety features, such as arc fault circuit interrupters of size or ground fault circuit interrupters (GFCIs). When making repairs or upgrades to an older electrical system, it's essential to adhere to certain best practices. One best practice is to conduct a thorough inspection. A comprehensive inspection can identify potential hazards and code violations. Another best practice is to use appropriate materials. Utilizing materials that meet current code requirements ensures safety and longevity. A third best practice is to obtain necessary permits. Permits ensure that the work is inspected and approved by the local authority. Let's talk about grounding and bonding. Grounding provides a path for fault current to return to the source, helping to prevent electrical shock. Bonding connects non-current carrying metal parts to create an electrically safe path. In older homes, grounding and bonding may be inadequate or non-existent. Upgrading the grounding and bonding system is often a critical step in improving electrical safety. Arc fault circuit interrupters of size and ground fault circuit interrupters (GFCIs) are essential safety devices. SIs protect against arc faults, which can cause electrical fires. GFCIs protect against ground faults, which can cause electrical shock. Installing SIs and GFCIs in appropriate locations can significantly enhance electrical safety. The NEC specifies where these devices are required. For example, GFCIs are typically required in bathrooms, kitchens, and outdoor areas. SIs are often required in bedrooms and living areas. Electrical panels play a crucial role in distributing electricity throughout a building. Upgrading an electrical panel may be necessary to increase ampacity or to add more circuits. When selecting a new panel, it's essential to choose one that is appropriately sized for the electrical load. It's also important to ensure that the panel is properly grounded and bonded. Wiring methods have evolved over time. Older homes may have wiring methods that are no longer permitted by the NEC. Replacing outdated wiring with modern wiring methods such as non-metallic sheet cable, commonly known as Romex, can improve safety and reliability. When replacing wiring, it's essential to follow the NEC guidelines for wire size, insulation type, and installation practices. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. It's crucial to ensure that the overcurrent protection devices are properly sized for the circuit they protect. Using the wrong size overcurrent protection device can create a fire hazard. Electrical boxes provide a safe enclosure for electrical connections. It's essential to use the correct type of electrical box for the application. Metal boxes are typically required for metal conduit systems, while non-metallic boxes can be used with non-metallic sheet cable. Electrical boxes must be properly supported and secured. Lighting is an essential part of any electrical system. When upgrading lighting in an older home, consider using energy-efficient LED lighting. LED lighting consumes less energy and lasts longer than traditional incandescent lighting. It's also important to ensure that lighting fixtures are properly installed and grounded. Electrical outlets, also known as receptacles, provide a convenient way to plug in electrical devices. When replacing electrical outlets, consider using tamper-resistant receptacles, which help to prevent children from inserting objects into the outlets. It's also important to ensure that outlets are properly grounded. Switches control the flow of electricity to lighting fixtures and other devices. When replacing switches, consider using dimmer switches, which allow you to adjust the brightness of the lights. It's also important to ensure that switches are properly grounded. Smoke detectors are essential safety devices that provide early warning of a fire. Install smoke detectors on every level of the home and in each bedroom. Test smoke detectors regularly to ensure that they are working properly. Replace smoke detector batteries at least once a year. Carbon monoxide detectors are also essential safety devices that provide early warning of carbon monoxide poisoning. Carbon monoxide is a colorless, odorless gas that can be deadly. Install carbon monoxide detectors on every level of the home and near sleeping areas. Test carbon monoxide detectors regularly to ensure that they are working properly. Replace carbon monoxide detector batteries at least once a year. Surge protection protects sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic devices. Install surge protection devices at the electrical panel and at individual outlets. Electrical safety inspections can help to identify potential hazards and code violations. Hire a qualified electrician to perform an electrical safety inspection of your home. The electrician will inspect the electrical system and provide a report of any findings. When working on electrical projects, it's essential to follow safe work practices. Firstly, always turn off the power to the circuit before working on it. Secondly, use insulated tools. Thirdly, wear appropriate personal protective equipment, such as safety glasses, then gloves. Fourthly, never work on electrical projects when you are tired or distracted. Fifthly, if you are not comfortable working on electrical projects, hire a qualified electrician. The NEC provides detailed requirements for electrical installations. It's essential to be familiar with the NEC requirements that apply to your project. The NEC is updated every 3 years, so it's important to use the latest edition. You can purchase a copy of the NEC from the National Fire Protection Association, NFPA, or from many online retailers. Understanding the NEC requires a grasp of its structure and key articles. The NEC is organized into chapters, articles, and sections. Chapters cover broad topics such as general requirements, wiring and protection, and equipment for general use. Articles cover specific topics within each chapter, such as grounding and bonding, overcurrent protection, and wiring methods. Sections provide detailed requirements for specific applications. Some key NEC articles to be aware of include Article 90, which covers the purpose and scope of the NEC, Article 100, which provides definitions of terms used in the NEC, Article 110, which covers general requirements for electrical installations, Article 200, which covers the use and identification of grounded conductors, Article 210, which covers branch circuits, Article 215, which covers feeders, Article 220, which covers branch circuit, feeder, and service calculations, Article 230, which covers services, Article 250, which covers grounding and bonding, Article 300, which covers wiring methods, Article 310, which covers conductors for general wiring, Article 400, which covers flexible cords and cables, Article 406, which covers receptacles, cord connectors, and attachment plugs, Article 408, which covers switchboards and panel boards, Article 430, which covers motors, motor circuits, and controllers, Article 440, which covers air conditioning and refrigerating equipment, Article 500, which covers hazardous classified locations, Article 517, which covers healthcare facilities, Article 547, which covers agricultural buildings, Article 550, which covers mobile homes, manufactured homes, and mobile home parks, Article 600, which covers electric science and outline lighting, Article 625, which covers electric vehicle charging systems, Article 680, which covers swimming pools, fountains, and similar installations, Article 690, which covers solar photovoltaic systems, Article 700, which covers emergency systems, Article 701, which covers legally required standby systems, and Article 702, which covers optional standby systems. When performing electrical calculations, it's essential to use the correct formulas and tables. The NEC provides many tables that are used to determine wire size, conduit size, and overcurrent protection size. Some common electrical calculations include calculating voltage drop, calculating ampacity, and calculating short circuit current. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction. Ampacity is the current carrying capacity of a conductor. The ampacity of a conductor must be sufficient to carry the load it serves. Short circuit current is the current that flows during a short circuit. Overcurrent protection devices must be able to interrupt the short circuit current. Let's consider a specific example. Suppose you need to install a new 20 amp circuit in an older home. The first step is to determine the load that the circuit will serve. Let's say the circuit will serve a lighting load of 1500 watts. The next step is to calculate the current that the load will draw. The formula for calculating current is current equals power divided by voltage. In this case, the current equals 1500 watts divided by 120 volts, which equals 12.5 amps. The next step is to select the appropriate wire size. According to NEC Table 310.15, B16, a 12 AWG copper conductor is required for a 20 amp circuit. The next step is to select the appropriate overcurrent protection device. A 20 amp circuit breaker is required for a 20 amp circuit. The final step is to install the wiring and the overcurrent protection device in accordance with the NEC. In conclusion, Navigating electrical repairs and upgrades in older homes requires careful consideration of the NEC, local codes, and potential liabilities. By understanding the relevant regulations and best practices, homeowners and electricians can ensure safe and compliant electrical installations.